In this episode of KubeFM, we're joined by John McBride from the Linux Foundation to break down the challenges and solutions behind running AI inference workloads efficiently on Kubernetes. We'll cover how his team deployed VLLM to serve open source LLMs while optimizing GPU utilization, the role of dynamic resource allocation, DRA, in managing GPU nodes, and why Kubernetes' native scaling capabilities made it the right choice for inference workloads. John shares real-world lessons from running large-scale AI infrastructure, including overcoming GPU driver issues, reducing cold start times for massive models, and designing cost-effective cloud deployments that save tens of thousands of dollars compared to managed AI services. If you're working with Kubernetes and AI, this episode is packed with technical insights on optimizing inference pipelines, selecting the right models, and keeping costs under control while maintaining performance. This episode of KubeFM is powered by StackGen. StackGen helps development teams work faster and more securely in the cloud. Whether you're moving to a new cloud platform or trying to improve your current setup, StackGen makes it simple. Their tools automate the complex parts of cloud infrastructure so your team can focus on building great products. Ready to make your cloud journey easier? Click the link in the description to learn more. Now, let's check out the episode. Hi, John. Welcome to KubeFM. What are 3 emerging Kubernetes tools that you are keeping an eye on?
Hey, it's good to be here. 3 emerging Kubernetes tools that I'm keeping an eye on. Great question. I thought about it long and hard, but there's a few. Something called DRA, which I'm very excited about in Kubernetes, is coming. And I believe it's in beta in like 1.32 now or something. But this is dynamic resource allocation. And this will be a way, which I experienced this pain with, some of the VLLM stuff we're going to talk about. But this is a way to get drivers and different resources onto your Kubernetes nodes dynamically without having to go through cloud provider specific, like, oh, I need the NVIDIA driver. I'm just going to use, AKS's NVIDIA driver plugin thing to get that onto all my nodes, to get GPUs to work, to then get inference on my AI Kubernetes platform to get going. So very excited about DRA, but that's a little deeper down. Some of the other things I'm excited about are something called Dapper is something I've been looking at a lot recently, which is kind of like, it seems like something between like a Kubeflow or even like maybe like I guess Airflow or Kafka kind of thing. But it's an event-driven platform for real-time events and across your distributed cloud and edge environment. So you could have, any kind of crazy setups where maybe you have edge Kubernetes clusters in your retail that have event-driven sort of things happening that phone home back to your control plane, or maybe a huge cluster with a ton of nodes doing all different kinds of event-driven things. So yeah, Dapper looks very cool. Been experimenting with it, and yeah, definitely recommend people checking that out for that use case. The other one that I think has been super fun, and I don't know if it's new, but it's newish to me, and I've been playing around with, is something called Kraken from Uber. And this is a peer-to-peer Docker registry that focuses on scalability and availability. And the idea is that in a peer-to-peer network, you can kind of more efficiently share layers of your images so that container startup times can, in theory, be much faster, instead of having to just pull down like all the layers of an image into a node to then have container startup, get going. You can have this peer-to-peer container registry network to just get image layers wicked fast. So I think that's super cool, especially in the age of AI, where image layers seem to be ginormous. If your image with a AI inference model is like less than 2 or 3 gigabytes, then you're probably doing pretty good. That's pretty small. Anything upwards of like 5-10 gigabytes or something is probably more typical for something with an LLM on it, or any different kinds of AI or ML job. So very cool. Check out the peer-to-peer network on Kraken.
Now, for folks who don't know you, what do you do and who do you work for?
Great question. Who am I? So I currently work for the Linux Foundation. I was at a company called OpenSauced that was actually acquired by the Linux Foundation, and we're sort of focused on making the LFX Insights platform better and bringing a ton of various insights and understandings to open source ecosystems and your program offices and stuff. But at OpenSauced, we were focused on that same area. And I particularly was deep down in the Kubernetes backend infrastructure, building a lot of the intellectual property deriving and building a lot of the stuff from the big data that we were consuming off of GitHub to give people things like your health metrics and checks and stuff like the lottery factor, and as well as deep dives into individual contributions and different things like that. And on top of a bunch of that was a bunch of AI jobs that we built to kind of give a better understanding, just of the natural language semantics that people might be using to describe pull requests or issues, or to even do like more intelligent search. So that was OpenSauced. Before that, I was at AWS working with Amazon Linux and BabaRocket. And before that, I was at VMware doing some upstream Kubernetes stuff. I worked on the Tanzu Kubernetes platform. Before that, I was working on Cloud Foundry, which, anybody who's worked on Cloud Foundry before, my heart goes out to you. I hope your needs are okay. And yeah, I'll stop there. It's a bit of a saga, but found myself working in a lot of Kubernetes and loving it along the way.
And how did you get into cloud native?
I mean, it is funny, and I feel like kind of by accident, honestly, which maybe a lot of people say this, but I was working at Pivotal, which, was kind of predating the whole like Kubernetes ecosystem storm of things. And at Pivotal, we had a product called Cloud Foundry, and well, I guess really it was like the open source version of Pivotal Cloud Foundry. But Cloud Foundry was sort of a cloud native-ish thing. I don't even know if I would call it cloud native. I mean, it exists in, sort of the Linux Foundation and CNCF ecosystem of things today. But at the time, the commercial offering was, like you're an enterprise with a data center. You have a bunch of VMs, and Cloud Foundry is going to help you spin up and spin down those VMs to do your workloads, which is kind of a gross oversimplification of how Cloud Foundry worked. But you'll notice that the kind of core paradigm inside of Cloud Foundry was virtual machines, essentially, where cloud native today in Kubernetes is really revolving around containers, which is kind of a higher order abstraction, I would say, versus like a straight up VM with like its own kernel and its own resources and its own virtual memory and all that stuff. So, we really, I guess the market honestly kind of decided that that wasn't going to be the thing. And, it was obvious that the shift was going to be onto Kubernetes. And for anybody who's a studied historian of these things, Pivotal was acquired by VMware, which eventually a bunch of that just got wrapped into the VMware Tanzu ecosystem of tools. Tanzu then was kind of VMware's like opinionated platform for Kubernetes on top of vSphere. You could really deploy it on any cloud. You could deploy it on Metal. And yeah, I joined the team that was doing the first open source variant of that at VMware called Tanzu Community Edition. And that was kind of like, all right, here we go. Like we're all in Kubernetes all the time. We're shipping, Helm repositories. We're building Kubernetes nodes. We're deep in like a bunch of this templating stuff. There was some tooling called YTT and Carvel that was kind of originated within that ecosystem of projects. So yeah, it was almost by accident, by acquisition, more or less, going from Cloud Foundry into kind of the Kubernetes ecosystem of things.
You've been in Kubernetes ecosystem for a while. It's an area that moves very quickly. How do you stay updated? How do you keep track of all the different things that are going on? What are your go-to resources?
Oh my goodness. Yeah, it's a good question. People actually ask me this all the time. And sometimes I feel like I don't have a great answer because oftentimes I feel like I'm falling behind. And it's easy to feel that way. I would say this is less a practical answer and more philosophic. At least for me, the really important stuff inevitably does, surface. And inevitably you'll hear about it. You'll start to, kind of get signal here or there if you're already like, building Kubernetes or building controllers or building on top of it and stuff. There's a lot of noise. Like there's a ton of noise. And I've been, getting deeper and deeper into kind of the AI infrastructure side of that, where it's like GPUs and, I mentioned VLLM and DRA and a bunch of these other things that, you can do for AI and stuff. But the noise factor on a bunch of that is even more so. So, I would tell people use the resources that you like. Like, I think there's some practical resources like Hacker News There's a bunch of great communities on Reddit, like the R Kubernetes subreddit is really great, actually. And then be aware of the noise and like be very okay filtering that out. And I would say be very aggressive with how much you filter out, because you'll get so lost in the sauce if you just try to, continue to keep up with all the, the coolness and the sexiness and everything that people are doing. Because there's a lot of cool and sexy things happening out there, but a lot of it is noise, which is just fine, and it's okay to kind of filter for that.
If you could go back in time and share one career tip with your younger self, what would it be?
I think first principles have been really important for my career. I just mentioned, in there that Cloud Foundry was kind of this paradigm around, virtual machines, and, containers were kind of the future and stuff. And obviously in hindsight, if I could have been like, well, containers were always just the future, I would have gotten way more heavy into like learning about containers and building for containers and controllers and stuff on top of Kubernetes and Docker and a bunch of those things way in the past. But that's so easy to, in hindsight say. So, I think though, stripping that back, I think the first principles thinking is really important, and just going back to like the things that are really important, not only within like the cloud native ecosystem, containers, the 12-factor app, things that should be stateless on top of Kubernetes, a bunch of those things, but also just like first principles of, working well. Like, again, I would say the first principles for me on like understanding the ecosystem and staying up to date is filtering for noise, and just like being aware of like feeding my mind, but minding the feeds. Like the feeds can just overwhelm you. And I think that's just been kind of a first principle for me to go back to. So if I had to give that advice to, younger self, it would be to be very aware of those first principles and learn well from them, and continue to, adopt them, and not get too caught up in, different things going on. It's kind of a non-answer, but
It's good enough. I have no problem with it. As part of our monthly content discovery, we found an article that you wrote called "How We Save Tens of Thousands of Dollars Deploying Low-Cost Open Source AI Technologies at Scale with Kubernetes." No pressure with that title. So to dive in a little bit further, before we get into the technical details, I'd like to understand the problem you were solving. What exactly is StarSearch, and what challenge were you addressing with this AI feature?
Yeah. So I'll start with the challenge, and really at OpenSauced, kind of what we were hearing from customers, and ultimately we wanted to bring, even pulling back the kind of startup manifesto a bit on this, but like we wanted to bring an AI feature to the market through OpenSauced, and I think part of that was, again, the sort of dramatic buzz going on with AI stuff, as well as being able to kind of in our portfolio say like, we can build for this, see where the market stickiness would be around a feature like this. Ultimately, OpenSauced was sort of a business to business platform, really, where we were kind of targeting top down for open source program offices and executives to be able to look at, their investment into open source ecosystems. A great example that really resonated with me is like the VMware sort of story, was that VMware was pouring a ton of engineering resources into upstream Kubernetes, and they had built a bunch of custom tooling to kind of understand that return on investment, to be able to see like, okay, Kubernetes releases are still going strong. We're fixing bugs at an adequate pace. Our engineers are, doing things that are valuable to the downstream Tanzu ecosystem of products that we're selling. So that's kind of the OpenSauced product ethos in a nutshell. But ultimately, we heard from customers that like, an AI feature would be something they'd be interested in, and that we could bring to market, and really was around like that natural language semantic understanding. So just being able to say something to this product, like, tell me about people who built Kubernetes 128, and it can kind of start to tease apart those GitHub releases, look at those usernames, look at who those people are and the things they're contributing to, kind of parse through in a natural language semantic way the commits and a bunch of the pull requests and stuff, just through that kind of natural language question, which you could start to, for a technical person, you could get pretty far with just Git, and looking at GitHub profiles and things. But we thought that this kind of predated even the like agentic sort of things you hear a lot about in the market today, where it's like we're building an agent. But that was sort of how we were thinking about it even like a year and a half ago, was like what is kind of an advanced piece of automation using AI generation at the time to actually be able to tease out from those natural language semantic questions real insights and understandings. So that was kind of the idea about how StarSearch could work and all that. And obviously in there's a bunch of stuff around LLMs, and like you can even today just throw a bunch of information into like ChatGPT or something, even big chunks of like structured data, and it does pretty well, right? It can kind of start to be like, oh, I see, with this CSV you gave me, like I can start to understand, this cost analysis, whatever. Maybe it'll hallucinate a bunch of stuff, which was a problem, but I'll get into that. So the idea was that we would use LLM inference, really that kind of ChatGPT experience where it's going to generate a bunch of text based on inputs. We would use that with RAG techniques, which is retrieval augmented generation, to actually pull in relevant information based on that input question, that input query. And we can get into kind of how RAG and a bunch of that stuff works. But ultimately, we have the content, we have embeddings, which are kind of the like embedding model understanding of that input content. And then we can actually do some kind of interesting search functionality, like a vector search, cosine similarity, nearest neighbor. We ended up using something called HNSW, which is hierarchical. What is it? Hierarchical something small worlds. I will get into it. It's a bunch of vector math on like how you can pull in relevant content from or relevant chunks of vectors from an input vector, and basically it gives you the ability to be like, I want to know about people who cut the Kubernetes 128 release, and it can kind of take that and understand that, and then pull in the relevant content based on that vector understanding. So we're getting to the Kubernetes stuff. So that's kind of how the product worked, I guess, very simply under the hood, with a bunch of like agentic flows and stuff. But really what we needed then, once we had the kind of RAG stuff set up, the retrieval augmented generation with a bunch of the vectors and the vector databases and the actual content that we'd be retrieving, we needed to then feed that into a large language model to actually then give the kind of response and answer. And what we found in kind of this whole flow with the content and the embeddings and the actual LLM answering the stuff is it did okay, but it often would hallucinate on just like very kind of typical things that you would see in the issues and pull requests, stuff like, oh, this is being tagged as a bug, or this is, like random cruft, or like random like brackets of code that people would put in, or like brackets of error messages and things. And mind you, we were trying to scale this to like a pretty huge scale to bring this to market in kind of an impressive way. So the idea was the top 40,000 plus starred repos on GitHub, which are quite a lot, but encompass the really big ones like Kubernetes, or Facebook React, or Vue, or even the Golang source code, a bunch of this stuff. So we wanted to kind of en masse capture a bunch of this stuff. So just the wild variability of like where these things were coming from was kind of a challenge to give correct answers further down the pipeline, further down kind of the data pipeline. But one of the ways that I solved for this was actually, when we consumed that content, actually getting a large language model, even before it hits the vector store, to actually just like summarize it and give kind of a sane sort of standardized summary of like, what is this? Like, this is a bug report. This is a feature ad that does this, this, and this. This is, whatever, which very cleanly actually can get rid of, just asking it to do a summary, which I would argue is probably one of the best things that LLMs can do today. It's just like give you a summary of a bunch of text. With the way that these sort of predictive models end up working, they can just summarize these things pretty well, actually. So in this kind of data pipeline, what it ended up looking like in total to kind of get rid of a bunch of those hallucinations was we consumed a bunch of content in mass from GitHub. That's issues, pull requests, a bunch of that stuff. We then would kind of summarize a bunch of those things from the top 40,000 plus GitHub repositories. So summarizing the issues, summarizing the pull requests, a bunch of that stuff. From there, we could actually then go vectorize it, do the embeddings, store it in the vector store, which then would enable us to do the RAG flow, the retrieval augmented generation, which then would allow us to actually answer the question all the way on the right side of the pipeline to actually give the end user that value. Now, the biggest piece in there that ended up being like a pretty huge cost center, as we tried to solve the problem, we realized that this was going to be very expensive, very, very expensive, because we're consuming 40,000 GitHub repositories in real time. Any of these projects at any one time can have tens and tens, even hundreds of issues and pull requests flowing through every day. That just kind of compounds and becomes like, hundreds of thousands of issues and pull requests every day that are just kind of flowing through this data pipeline that I built. And hundreds of thousands of inference jobs on anything like OpenAI or Anthropic would be hundreds and hundreds of thousands of jobs. Hundreds and hundreds of thousands of dollars for those jobs every year. So the back of the napkin math was kind of ridiculous. It was like, even conservatively, it was like, this is going to be $300,000 for, just this one thing that we're trying to bring to market. So, at the time we were kind of like, well, do we do this? Like, do we scale it back? Like, and in my kind of, scaling engineer brain, I'm like, there's ways to do this without, having to go spend a crap ton of money on a third party provider. There's open large language models like the Mistral models, which are permissibly licensed, which was a huge thing for us. Or we could have used something a little more powerful like the Llama models. There's, Kubernetes, which I was very, very familiar with, and was like, this is how you scale compute, is, using one of these kind of modern cloud native computing platforms. There's good support for doing inference on these open platforms as well. Stuff like VLLM, which is kind of a OpenAI-like API that you can run to actually, with a open model, to actually give you that inference like you would on OpenAI. There's things like llama.cpp. There's OLlama, which seems to be ubiquitous today. There's a bunch of these that just make that piece of the pipeline possible. So I remember getting people together and being like, let me give this a shot. Like, give me a week, and I'll quick stand up a cluster and get together the VLLM components and the data pipeline and all this stuff, and we can then compare and contrast that kind of data projection of like what the cost would actually look like on top of our own infrastructure with our own GPUs in the cloud, that we can then kind of make a decision on like the cost factor in this. And long story short, it ended up being dramatically cheaper, like basically just as cheap as like a cluster or two in the cloud with some GPUs that are being on lease in the cloud, which ends up being much, much cheaper than, hundreds and hundreds of thousands of dollars a year. So that's the data dump. That's the brain dump on like how this whole thing kind of worked and how it kind of came to be.
Once you selected VLM, you needed infrastructure to run at scale. What made Kubernetes the right platform for this deployment? Walk me through the process of how you ended up deciding on Kubernetes.
Yeah. I think for me, what was really, really tantalizing about using Kubernetes for this case was not only the compute scaling capabilities, where we could, pretty dynamically scale up and down GPU resources that we needed in the cloud to be able to say like, oh, like there's a lot more inference jobs coming in. We need to scale this to, many tens more of GPUs. Oh, there's not a lot happening. We can scale that down. And those are pretty well understood. Those are pretty well understood patterns, I would say, these days in Kubernetes. The other thing that was really, I think appealing to me was also that we could kind of run a service internally inside of the cluster. So it ultimately ended up being an internal Kubernetes service behind Kubernetes DNS and Kubernetes load balancing that was like VLLM.service.local.cluster or whatever it ends up being, right? We could hit that internally with our microservices without having to do a lot of the song and dance of like going through a third-party provider. It was just like all on cluster, which was local and pretty pretty simple ultimately to kind of prove out and then ship. So just good old fashioned, Kubernetes services, which then we could expand, knowingly expand into the future into being a better service mesh, or even using like an internal load balancing, different algorithms and stuff. Because admittingly, Kubernetes internal load balancing, I don't think it's the greatest solution for this. Startup mode, it worked great for us, but we understood that the capabilities of being able to have like an internal traffic that we could build a small piece of middleware for, to have like an internal ingress working correctly, load balancing a bunch of that stuff much more simply, was a future possibility and capability. So to me, it really was like a pretty weighing the balance of like, hey, we're going to hand roll a GPU platform is basically what it was. Like, we're going to hand roll this thing and sort of understand the operational cost. And I was willing to take on that burden, versus running something at a much more expensive cost to the kind of detriment of our bank, I guess. So even more wax poetic, I would say that it was kind of a economies of scale issue that we hit, where we wanted to scale this thing to such a high degree that it basically would have just been untenable, in my opinion, to do it any other way from a cost perspective, because that many inference jobs on a third-party provider, I mean, we basically would have had to go find like an enterprise agreement with one of these companies anyways, to be like, hey, we're going to be doing this, and we need this kind of availability to be able to like scale our product. And it's going to be every day with a bunch of this stuff. And we're hoping that you can, reach this availability and stuff. So even when problems would creep up, like operationally, I would say that's a win, that I could just go and fix it immediately versus having to rely on like an OpenAI being down for half a day or something. Which, is maybe a hot take. I think people, or at least I sort of feel that there's a bit of a mood shift in kind of some of these areas of like just services in general. It seems that third-party services seem to be more wildly, I guess, volatile than they used to be. And maybe that's just because I'm paying attention more, but things are down quite often, which, I would much rather run a small service myself that I know that I could go fix whenever a problem does happen. And maybe that's hubris, but yeah, it was kind of an economies of scale thing where we wanted to take on that operational burden. We wanted to be able to run the service. We wanted to be able to, scale that cost however we needed to scale the cost, and not sort of be at the whims of this third-party provider. But yeah, Kubernetes was great. It worked really, really well for us. I think Kubernetes at its core is an amazing platform for scaling compute, including GPU compute. And honestly, in my opinion, Kubernetes is the platform of the future for AI, ML. Like, there's really no other choice in my mind. Like, if you're at the economies of scale already, where you have GPUs or you're renting GPUs on lease from the cloud, it's great to just be able to scale up, scale down that node pool whenever you need, and just have it sort of just work. Yeah, that's my answer. I'm sticking with it.
Okay. Now, the GPU configuration seems critical to making this work efficiently. How did you configure the VLLM daemon set to properly utilize these GPU resources?
I think that was actually one of the more challenging things that we ended up sort of walking through in an exercise of like, how do we solve this for the Kubernetes we have, so that we can actually run this thing dynamically, bringing resources up and down and stuff. And I would say, not well. Again, startup mode. We were on Azure. We were on AKS, and AKS just has like a sort of hand-built solution for getting the NVIDIA drivers for the nodes that we have. So really, it ended up being their controller on our cluster that could just watch for nodes that we labeled with, what was it, like skew NVIDIA or something like that. And it just would watch for that label and then be like, okay, you get the daemon set with the NVIDIA driver. This is partly why I'm so excited about DRA is, we were totally fine going with Azure and AKS and all that stuff. But the the cluster API person within me, way back from the VMware days, was a little bit sad, because anytime you're kind of relying on a, I guess, proprietary upstream cloud provider in your Kubernetes cluster, I would say that's not always great, or at least like your portability you lose points in portability at least. I would have loved if there was a solution that was just like, we get these NVIDIA nodes and it just works and the driver's there, and we can just immediately start doing inference on those GPUs without much of a worry. And it just works. So that's one of the reasons I'm very excited about DRA, is just because being able to dynamically get those resources based on all those, node types and SKUs and different things, be it the NVIDIA GPU drivers, that's great. So the NVIDIA driver part of it is a challenge. And I would say, I don't know if that's very well solved today outside of, what the upstream cloud providers are just giving you, which again are great solutions. The next thing was actually getting VLLM on each of those. So the sort of arbitrary approach we took was each node with a single GPU can get VLLM, and we'll just do a daemon set so that each of those nodes that are labeled that way can get that runtime. And then VLLM will kind of handle the job of actually pulling in the model and then start serving that model. And then serving that model just looks like OpenAI's API, which is awesome, because so much stuff has just looked like OpenAI's API for, since the dawn of ChatGPT, basically. And then we could put a service behind that, and then we're off to the races doing, inference inside of our cluster. One of the challenging parts of that is actually VLLM getting the model, which we looked at a bunch of stuff with, pre-baking images, or even building, our own node images at one point, which we kind of quickly abandoned because we didn't want to be building, an OS for a GPU. So VLLM, yeah, it'll go and actually query Hugging Face for that model that you specify in the config, which works, but then you're waiting, a minute or two for that node to come up, because it's still waiting for its model to be downloaded and available. And again, some of these models can be upwards of 2, 3, 4, 10 gigabytes and stuff, depending which model you pick. So that can take some time. There's people looking at this and trying to solve this. This is one of the reasons I have looked at Kraken in the past, or any of these peer-to-peer networks, is, just having a much faster way of sharing those node layers, or really like any piece of data, be it in a container image or whatever across your node network, is much faster than going and asking Hugging Face for it. So that was another challenge that I think kind of went unsolved, as we sort of, at least in our case, we just sort of continued to plow forward, and we're like, this will work for now. Like, we need to bring this to market, and startup mode, just kind of ship it, which worked. Yeah. So the two challenges I would say in there are the GPU NVIDIA driver stuff, and then the VLLM actual runtime.
Now, this sounds like a significant infrastructure investment. After implementing the solution, what kind of cost savings did you see compared to using OpenAI?
Yeah, great question. So again, economies of scale, I would say our cost savings were astronomical, it was amazing, honestly. Instead of tens of thousands of dollars every month, it was maybe a couple thousand at the biggest scale, definitely less. And again, startup mode, we were able to utilize credits that we were given as part of like different like cloud provider agreements and stuff. And we, at least, I think for a small 8-person company was much easier to kind of go about with our existing relationships with Microsoft. And we had gone through something called the Microsoft, what was it? Microsoft Partner Program or something. And our founder, Brian, was really, he had a bunch of great relationships with those people. So it was kind of that versus being able to go and create an enterprise agreement or start those relationships with people at OpenAI. For anybody thinking about going and joining an early stage startup as a founding engineer, or going and doing your own thing, unsolicited advice, one of the things I was most surprised about was actually the amount of like relationship building and actual just kind of talking with people in Silicon Valley that you end up doing. which is kind of crazy. It's a lot of back scratching actually, which is great. That's just business, I guess. Anyways, so yeah, the cost savings were great for a cluster with the control plane on AKS is like maybe a couple hundred a month. So not much there, I would say, for a production grade cluster on AKS that's managed for us. So we're not managing the control plane or bringing up and down or upgrading and downgrading versions if we needed. That's all just managed on Azure, which is great. The other big cost center in this was the GPUs. So we went with basically the cheapest ones we could get, which were the T4s. And T4s are great because they're sort of, I think most people would consider them more like edge compute kind of grade, where you still are, they're still enterprise grade, so they're not like a 3800 or like a gaming GPU or something, but they're not much more than that. So we had to be pretty mindful of which models we were trying to load up onto these things, partly just because anything bigger than like 7 billion parameters or 14 billion parameters would just overload it, and we'd run out of VRAM, and then the GPU would just kind of puke and the node would have to restart, which that's not great in the service. Like, I'm operating this thing, so of course I want it to be about as good as possible. So we had to find that kind of middle ground between like a GPU that was cheap enough and easy enough for us to like scale up, scale down. We could even get spot instances of the T4s on Azure, which was really cool because it was really cheap and much easier to scale up and down as we need. So yeah, a sort of scaling exercise between like which GPUs, which model to pick that sort of fits in that GPU's VRAM, but then also isn't going to hallucinate a bunch. We need it to be about as good as we could get within those constraints. So again, the Mistral models were amazing, like hugely recommended. So Mistral is doing amazing stuff, licensing these permissively and letting people use them and grab them and run them on these platforms like this. So I'll be forever rooting for Mistral because of that.
Now, AI workloads can be unpredictable in production. What monitoring approaches have you implemented to ensure your system runs smoothly?
Yeah, that's a great question. That was going to be the other thing I was going to say, just about running this kind of hand-rolled GPU platform and like the daemon sets and like getting the GPU drivers and stuff. And even though Azure has a basically proprietary controller for that, it would puke every once in a while, which I was a bit surprised at kind of doing a bunch of the research then to understand that like GPU workloads in the cloud are actually pretty unpredictable. Like, it's not uncommon for a GPU like in the data center to just die, and then they got to go in there and like take it off the rack and take it off the network, and like it gets ejected from your cluster, and you're just kind of like, oh wow, like I thought we had 10 T4s and now we're down to 8 because a bunch got ejected. Wow, that's surprising. Oh, they're coming back up. Okay, maybe it was an exercise within like an hour or two for the control plane to go and find you new nodes and stuff. So yeah, we definitely had the benefit of using AKS, which I think made a lot of that pretty easy, where, even if things were unreliable and getting ejected, we kind of were at an okay-ish enough scale where even if things went down to like half capacity or something, it usually would come back up as they would scale and bring our node pool back up and stuff. So use it. That's one of the things I really like about managed Kubernetes is it's managed, I guess. And some of those things you just don't have to deal with, because I've definitely dealt with them before on like a vSphere or with the Tanzu times, or even when I was on Bottle Rocket, like provisioning metal clusters is pretty gnarly. And I think it's great, especially if you have the hardware and you're willing to kind of go through those, again, just the operational considerations and what operational scale you want to hit to be able to operate metal clusters. But managed Kubernetes is great. So some of that we didn't have to worry about too much. But even little things, like even if the nodes weren't being ejected or like completely falling over, there'd be things where like VRAM would just kind of get eaten up in a weird way, or like a way that I was kind of didn't have time, or wasn't like happening frequently enough to like go and debug in a deep way or something, where the node would just like fail and restart and then come back up, and then it'd be fine and it'd keep doing jobs, and it'd keep doing stuff. And maybe that's at the VLLM layer too, where it ran into a weird thing and it puked and had to restart. It had to come back up or something. Yeah, I think we sort of had the again, I was just going on a rant about operational costs and economies of scale and all this stuff. At the same time, like we had very little time to actually go and like look at any of these things. So what we built was solid enough that we could ship a product and that it worked for our end users and our customers. And then kind of left that to future selves to go and figure out. But yeah, I realize not everybody, especially not in startup land, has the opportunity to go do that. So we also implemented, just sane observability practices. Like GPUs actually have great like metrics they emit. And I guess depending on your cloud provider or what sort of observability stack you're on and stuff, whatever you're getting might be a little bit different, but we could at least see like, okay, here's where, VRAM is getting used up. Okay, here's where maybe one of these nodes has like a long lasting inference job and it's just getting hit a bunch. Maybe we need to go restart it manually. A bunch of nodes got ejected. Just having those dashboards to understand kind of what's going on and just the overall like kind of vibe and health of the platform was definitely helpful and useful. So yeah, there's a lot of good practices I think happening with open telemetry as well right now, where they're sort of starting to think more and more about like GPU workloads, AI workloads, and inference, and then even like end user evaluations, which is a whole nother topic, but sort of stuff around like how can we be sure that this thing is like saying the right thing or saying something that's not crazy or going to get us in trouble, because that's something that can definitely happen in with LLMs. But ultimately, good first principles practice. Again, I go back to first principles. Managed Kubernetes was great for us, and yeah, just being aware of some of the kind of crazy nuances with running big GPU compute. Definitely something to be aware of.
Model selection seems to be a key factor in making this approach work. What advice would you give to teams trying to select the right open source models for their use cases?
That's a great question. And it definitely gives me pause, I think, because things are changing so quickly right now. Like, man, if you thought cloud native or like the programming world with like new programming languages and new frameworks all the time popping up and stuff, like AI and ML and especially large language models right now, it's just moving so fast. Like, whatever's happening in geopolitics with like DeepSeek, and there's all this stuff over there happening, and they're like making it even cheaper to run these things in the open and all this. And now we get OpenAI releasing new models that apparently are at some crazy PhD level, but you got to pay $200 a month or use their third-party service. I still deeply believe, despite all that noise and how fast things are moving, that you can get away with most things. I think you can get away with most things in a model with like maybe 95% with a pretty small model, like a 7 billion parameter or a 14 billion parameter model from Mistral or Llama. The Quen models that are small are pretty good. There was even a great thing I read from Anthropic about like how to build an agent and how to build like agentic workflows. And even they say in this article, like, yeah, you probably don't need agents. Like you can do most things with like a good one shot. And a one shot being like, here's a prompt, go and generate some text and then give that back to me and you're done. Versus like some crazy loop where it's just going back around and around trying to like do something or where it's like got some multi-agent swarm thing that it's trying to, pass a bunch of things between different agents, which can be a little crazy. But yeah, there's some good practices around like evaluating what can work for you on your given like use case. So download a model. Most of these can just run Llama, especially the small ones. Craft a good prompt, I think, is actually still very, very important, despite how powerful some of these models have gotten, even the really small ones, and how powerful they are now. The prompt engineering piece is huge. So that was a big part, I think, of this whole data pipeline as well. Because way on the left of the data pipeline, when we're consuming all that content and data from GitHub, I put a lot of effort into the actual prompt for summarizing that content, which then is really garbage in, garbage out. We realized like we were just kind of feeding it all kinds of cruft and crap from GitHub, which is fine. It's just like a wide variety of a bunch of things, people saying or pasting just giant code snippets, which can be confusing without context to LLMs. That's just like raw content from GitHub. But then crafting a good prompt to get it to summarize that stuff in a sort of succinct way to then feed the rest of the data pipeline so it's not all garbage in, garbage out. That was key. And I really believe that good prompt engineering practices can go an incredibly long way, which is in itself kind of its own own art form these days. So try out some of these models, craft a good prompt, and then see how a one-shot could work for your workflow. See if it can kind of get a bunch of things right initially, and then start thinking about like how you can expand it from there. And that depending on what you want it to do, could look like tool calling for the LLM, where you build a small sort of tool flow that it can actually go and use. It might look like taking that one shot and putting it in part of a data pipeline like we did. It kind of starts to become like its own practice in data engineering and starting to understand a bunch of these things. I did mention the kind of evaluation problem, which I think is kind of still unsolved, like being able to, I don't know, just because of how non-deterministic these things are. Like, it's pretty hard to be able to give something a prompt, get it to generate a bunch of stuff, and then say like, yeah, this is good, let's ship it. It's not going to be a problem or hallucinate or say something that's wrong for our customers or whatever. There's companies that have been looking at this. One that comes to mind is Brain Trust. Even Microsoft's Azure AI Studio has some like evaluation tooling as well. Once you kind of have a good idea, and we went through this practice as well, once you kind of have a good idea of like a model that should work for you, you've crafted a prompt that seems to work well enough, then you can kind of start to go through some of the evaluation steps, which some of these are really gnarly, where they actually use machine learning and kind of fuzz these models with your prompt to get a bunch of different answers to give you kind of an assurance that like, yes, thumbs up, we've evaluated this is going to work within this step and all that stuff. But that kind of becomes its whole own thing, I would say. We had the benefit of sort of a simple enough one shot that the small Mistral models worked for us. And again, like summarizing text, the biggest part of that with all that content and stuff coming in was probably one of the most simple things that an LLM can do today. Like summarizing a big blob of text is pretty simple for these things today. So anything more complicated, you'd want to go through kind of those practices of evaluation and all that stuff.
We've asked a lot of people about, how do they see the next 10 years of Kubernetes, given that we celebrated 10 years of Kubernetes last year. And it's very common that AI comes up in the answer, although I will say that a lot of times they have difficulties making that answer concrete or giving examples. I imagine that this might be a different case speaking to you. So thinking about, the AI landscape is evolving very rapidly. How do you see your architecture adapting as both open source models and Kubernetes tooling advance? What do you see the next 10 years of Kubernetes looking like as more AI and ML workloads make their way onto it?
That's a really good question. I actually have a very, very hot take here. I think the next 10 years of Kubernetes is going to be, especially in the AI ML space, I think that there could be another player that actually enters kind of the open source world of it. Maybe NVIDIA would be like, we have this compute platform that we're open sourcing and people can go and use and run and stuff. And maybe that's not a hot take, because even while Kubernetes has had its amazing tenure, there's been other, systems that have popped up. Docker Swarm, the thing from HashiCorp, which I forget the name of it, but it wouldn't surprise me if, a big company, somebody like NVIDIA or OpenAI, I think would have to do this, or maybe even Google in, doing Gemini, where they would look at some of these problems and say, it is hard downloading images onto a cluster, and like getting nodes to actually have, these 10, 15 gigabyte things, that's just not a very good Kubernetes paradigm. Because like, again, containers were kind of meant to be small, ephemeral, easy to spin up and down. And that's just painful for AI ML workloads today, at least with big LLMs. So, it wouldn't surprise me if there was sort of another player in this, or at least if there was another pretty big paradigm shift that happened where it was like, we love Kubernetes for its capability to scale compute, but it kind of stings that, we're having all these problems with drivers, and node and service boot up times. We want to be able to scale even faster and even better. So my hot take is that there could just be a whole nother paradigm that like evolves in the landscape, or that Kubernetes adopts a whole nother sort of way of thinking. Who knows? I'm not sure. I think, if I had to critique Kubernetes for anything, I think it would be sort of its pace and acceleration of how it's reacted to things like this in the past. Like, for as cool and sexy as LLMs and ChatGPTs and all that are today, this is not a new thing. Like GPU drivers and GPU workloads on Kubernetes have been pretty painful for basically the whole inception of Kubernetes. It's only now that people are like, give me more NVIDIA GPUs, that they're really, kind of twisting the arm of a lot of Kubernetes. I hesitate to say the word Kubernetes maintainers. It's really the like upstream companies that want to utilize Kubernetes as a platform, or that have Kubernetes products that they're trying to sell that are difficult to sell to people doing AI ML. That's really what it is, honestly. And I say that having come from VMware, where we were trying to sell a Kubernetes platform and product, and that target audience was mostly vSphere people, and that worked pretty well, I would say. I could only imagine how just disgusting that would have been trying to ship something for GPU AI ML workloads on the Tanzu platform. I don't know. I was at the very beginning of that, so it could have evolved past that. But maybe that's my hot take. That's my critique. I would challenge these upstream companies to continue to support the open source work, and if they really care about making Kubernetes the platform of the future for AI ML, which I very much believe it could be, then dedicate engineering resources into the open source community.
What's next for you, and how can people get in touch with you?
I'm going to continue building open source AI ML at the Linux Foundation, and operating the OpenSauced platform. You never know what's going on. The world is kind of crazy, but people can get in touch with me at johncodes.com. You can email me at hello@johncodes.com as well.
Perfect. John, thank you very much for spending some time with us today on KubeFM.